Multiplying fractions. We remember from class that multiplying fractions is just taking part of a part. Often when we're talking math, that keyword of tells us it's time to multiply. So if we look at the model to the left of the screen, we see the fraction 1/3 represented. That's a picture of 1/3. You can imagine this as something like a pan of brownies or a piece of cake that's left over in a pan. Right now we have 1/3 left. Now let's suppose someone comes along and they would like half of the third that is there. They don't want half of the pan, they want half of the third. So what we can imagine doing is taking the pan and splitting it in half in the other direction, and then shading that half in. And what we quickly see is that the overlapped part here, okay, that's the part where we have half of the third. We have, and in fact, that is equal to 1/6 of the whole pan, because it's 1 out of the 6 pieces that we created when we did that. Using this method is similar to making an array. So if we start out with another fraction, such as 1/4, okay, I'll draw my array here. I'm going to make my fourths all running in the same direction. And there's my 1/4. Okay. And let's say someone comes along and they ask for a third of that fourth. Notice I'm using that multiplication symbol there. So then I split it the other way into thirds. And I'm shading my third here. And that little piece that's overlapped, that is the amount that is the third of a fourth. And we can see that that is 1 out of the 12 pieces in the whole array. So 1/3 times 1/4 is 1/12. If we have a second example, let's say I started with 3/4. So I split it into quarters that way. I have 1, 2, 3/4 of those shaded in. And someone comes along and they would like a fifth of that. I would split them into 5/5 this way. And I shade 1/5. And we notice here this time there are 3 pieces that are shaded in both colors out of the 20 pieces in the whole array. So therefore your 1/5 times your 3/4 gives you 3/20. If we think about these problems and we start to try and look for patterns, because math is, after all about looking at patterns, we can start to notice some things when you look at the problems together. And what we want to look at here is our product when compared to the two fractions that we started with. And what we noticed in class was that our numerators multiply to give us our new numerator. 1 times 1 is 1. And our denominators multiplied to give us our new denominator. 3 times 2 equals 6. And we can check each of our cases and make sure that that's still the same. If we look at the second example here, that was example 1. Look at the second example. We have 1 times 1 is 1. The denominator 3 times 4 is 12. And then in the third example, 1 times 3 is 3. 5 times 4 is 20. If we take a look at the model on the right, we can see why this happens. Essentially, when we've multiplied these two fractions, we end up with what I'll call the little array and the big array. Okay? And your little array here is 2 by 2. It's a 2 by 2 array. That's the part that is shaded by both of the fractions. And 2 by 2 is 4. And then your big array is a 3 by 3 array. That's the total number of pieces here, and that's 9. And then, of course, when we look at the total area of that figure that's shaded, we have 4/9 because 2 times 2, or the small array, was 4. That gives us our numerator. And 3 times 3 was the area of the big array, and that was 9. So we have 4/9. So I know what you're thinking. Of course, Mrs. Bushnell, there are some special cases. What do we do, for example, when we have a whole number times a fraction? Or what do we do when we have 2 improper fractions multiplied? Or what do we do when we have mixed numbers multiplied by each other? So intuitively, you can look at this problem and you know that this is 2 pieces that are both 1/4. So in your mind, you're thinking, okay, well, that's just a fourth and a fourth, which is 2/4. Okay, and so to multiply here, what we need to remember is that we can just do repeated addition, or if we don't want to do that, what we remember is that that whole number 2 can be written as the improper fraction of 2/1, because 2 divided by 1 is 2. And then we can multiply by 1/4, and we just follow the same rule that we use to multiply fractions, which is multiply your numerators. 2 times 1 is 2, and multiply your denominators. 1 times 4 is 4. So we have 2/4 here. And then if we're being good mathematicians, we want to make sure that we simplify our answer. And we know that 2/4 is equivalent to 1/2. Then we want to know about improper fractions. And we know that these are in fact fractions, so we can just go ahead and multiply like we did before. We take our numerators, 9 times 7, which is 63. And we take our denominators, 3 times 2 is 6. And what we notice here is we do have an improper fraction that we're left with, but we are going to go back to a mixed number. Because that would be the proper way to leave our answers in mixed number format. And so when we do that, we have 63 divided by 6, which gives us 10 and 3/6. Uh-oh, not in simplest form, but that's easy enough. We end up with 10 and a half as our answer here. All right, so what about when we have mixed numbers? Well, sometimes what I see kids want to do when they get to this is they want to do this as though they're adding. They want to do the 3 times the 1 and then the half times the 1/2, but that would really be the same as, when you're doing 17 times 13. If you only did the tens place times the tens place and the ones place times the ones place, and we know that that just gets us the wrong answer. You need to multiply everything in the number times everything else. So we need to multiply the 3 and 1/2 times the 1 and 1/2. So we can either do this in pieces, or we can just change these into improper fraction format. And in this case, we would have 7/2 times 3/2, and that leaves us with 21/4 using the same strategies we've been using all along. And then, of course, we go back to a mixed number, which here we would have 5 and 1/4. So the answer here would be 5 and 1/4. So let's talk about what our general strategy will be for multiplying any kind of fraction we come across times any other kind of fraction. Step 1 will be to convert the numbers into fraction format if necessary. If you already have fractions like 1/2 and 1/3, you're fine as you are. But if you start with things that are whole numbers, such as 2, you want to rewrite it as 2/1. If you start with something that's a mixed number, like 3.5, you want to rewrite it as its improper fraction form, like 7/2. Step 2 is then to multiply the numerators, and that will be the numerator of your product. Your third step is to multiply the denominators, and then that will be the denominator of your product. So you can see what I did in the example. I did our 3 times 5 is 15, and our 2 times 4 is 8. And then our final step is we always want to convert back to a mixed number and simplify if possible. So in this case, I do have an improper fraction as my answer. So I want to take the 15/8 and change it back to mixed number format, which is 1 and 7/8. 7/8 is as simplified as possible. The numerator and denominator do not have a common factor. So now I know I'm done. So my answer there would be 1 and 7/8. And that's it. That was your review on multiplying fractions.